Today we are going to finish the collection chapter and talk about maps and sets. Now, if you are just approaching programming, you may be surprised to discover that hash maps and hash sets are actually some of the most used data structures in programming. They are exceptionally convenient and they are usually quite fast and allow you to do a lot. And they are exceptionally flexible. For example, a map can also be used as a sparse array. However, maps on user-defined types are a little bit tricky in other languages. A map from numbers to persons, or a map from strings to persons, it's perfectly fine. But a map from persons to cities starts to be problematic. You see, the general philosophy of hash maps is that they need to organize the keys using their hash value, and then they need to compare those keys, and if those keys are user-defined objects, then there need to be some user-defined criterion to compare those keys. And yeah, there are a bunch of ways in which this can go wrong. First, the equality method or the hashcode method can be buggy. And if they're buggy, the behavior of the whole hash map gets broken. Second, the keys may be mutable objects. And if they are mutated during the execution of the program when they are stored as keys, then again the map may be broken, because an object that was supposed to be a key for a certain hash code, now it's actually have another hash code, and so it should be in another cell in our hash map. And then there is a third problem. This is a little bit less known, but I think is possibly even more severe. If your keys are big objects, like you have this person object that has a lot of sub-objects and a lot of structured information, well, now to check the hash code of this person, and worse, to check the equality between two persons, it will take a long time. And so our hash map from persons to cities will actually be very slow. 42 solves all of those problems because of normalization. 42 maps will have deeply immutable keys in the type system. The type system will ensure that the keys are deeply immutable. So the problem of mutating the key while it's in the map is just not existent. The key is going to be guaranteed deeply immutable by the type system. Second, the keys are going to be normalized when they are inserted in the map. In this way, the runtime can check if two keys are equal simply by doing a pointer equality. So no matter how big is your object, the equality is always going to be exceptionally fast and correct. That is, if your keys are very large, in 42, you get out of the box a very effective and very efficient hash map that will be able to compare your keys in constant time, no matter if they are so big. So let's see some maps in action. Here in line 1 we have our mutable point class, in line 2 we have our list of points, and then we have a point to string that is a collection.map where the key is a point and the value is a string. And then we have our roads that is a map where the key is a string and the value is a point. And then we write some code to test out those types. We make our map as point to string square bracket, and then how do we initialize the map? Well, we have to provide pairs key value. So we can write key equals slash, because it's going to be a point. This is a map from points to strings. So slash x equal 3, y equal 4, val equal my base. And even if our point constructor creates a mutable point, since key wants an immutable value, the system is promoting our point from mute to im automatically there in line 7. And then we can add more lines to fill up our map. To iterate on our map, we can just write for key val in map, and then we can print out the values. That is, the iteration on the map return some entry object that have a key and a val field, and we can access them with the round bracket syntax. In the other video, we have seen that lists can have both mutable and immutable values. That's the same for maps. Let's see, for example, how to make a roads map that have both mutable and immutable values. So we have again our mapping from keys to vals, but when the value is immutable, we will write val, while when we insert the value as mutable, we write mute val. Then again, to iterate on our collection that have both mutable and immutable objects, we do exactly what we did for the list. We have to write for read key and val in roads, and now we can get all the values as read. When we read a value from a map, we get an optional out, because the map may or may not contain an entry for that value. That is, every time we create a map class, we implicitly also create an optional class that is a nested class of that map called oval. And so roads.oval will be the type that roads.hashval returns. We can write mute roads.oval opt point equal roads hashval key equal Cuba Street. And this will give us an optional value that for our map will actually contain our mutable point in 0, 0. And then we can do hashval.x and set it to 50, for example. And this will update the value inside of the map. Remember, the keys of the map are immutable no matter what. The values of the map can be either mutable or immutable. And finally, sets. Sets in 42 inherits all the good properties of maps. That is, they are very fast even if the keys are very big. Maps and sets in 42 actually are implemented as linked hash maps and linked hash sets. That is, they remember the insertion order. So the insertion order is deterministic. If you have a set and you add the elements 1, 2, 3, you will be able to iterate on them and see them in order 1, 2, 3. Same for the map. If you add the entries in a certain order, you will be able to iterate on them in the same order. So a little bit of a collection summary. There are many different kinds of collections, and each of those kind of collection come with a ton of methods. And while I'm not very eager to tell you that you have to just memorize things to be a good programmer, I think that collections are an exception. In order to be fluent in a certain programming environment, you need to memorize all the methods of the most important collections that are available in that environment. Yes, do it. That's really one of the main differences between a naive programmer and a professional programmer. A professional programmer really know how to use lists, maps and sets, and have an instinctive feeling for when it's a good idea to use one or the other. And it really remembers all of the methods and all of the contracts and all of the programming patterns about those 3 data types at least. No matter if you are coding in Python, in Java, in 42, in PHP, you really need to memorize the methods of those 3 types. In 42 in particular, there are quite a lot of methods, because you can manipulate collections both as mutable and immutable, and sometimes as reads. And you have to consider what happens when you put elements as im or elements as mute. I will argue that all of those complexity exists also in the other languages, but they are not exposed to the user. The user have to learn those complexity by trial and error, while at least in 42 the type system forces the API to expose those difficulties to the user. Okay, this is all for collections. See you next time!